This is a demonstration video of deliverables in Sprint 2. Within this sprint, we have been able to port the old functionalities to work on the now V6. We were able to make the robot speak, receive a child's information, receive the word to write and write the word, and ask the child for the feedback. Here we are recording on two windows on two laptops, one running the 3D simulated robot and one running the core program. To start the project, first we need to run ROS core, so that every component can communicate with each other. Then, make sure the robot is alive. Using simulated robot on choreography, we'll need to connect to virtual robot. After the robot is alive, we'll launch the program with the param now IP is set to the robot IP. After launching the program, we can see the initial state here is waiting for word. This is the initial state of the old code. We did not change this as the client does not expect this to be changed. When the program is at this state, it is waiting for signals from the GUI app to receive the word that the robot needs to write. Here we can just use ROS topic to simulate data sent from the GUI app. Here we are sending the word cow. After sending, the program can receive the word cow. Trajectory for each letter has been loaded and downsampled, and the robot started to write. After the robot finishes writing, the system will move to the state waiting for letter to finish. The robot waiting for a signal from the GUI app the robot drew on. This is to ensure all trajectory that the robot drew has been received and displayed. We'll simulate this action by using the ROS topic. After the robot receives the ending signal, it will ask the child for the feedback. At this state, if the child does not provide a feedback but the robot receives a command to change word, it will try to write the new word. The routine repeats, trajectory is loaded, the robot started to write. Finishing signal received from the GUI app, and the robot asks for feedback from the child. Now, when the robot asks for feedback, the child should do the demonstration of the word on the GUI app. The GUI app can be started from this comment here. The GUI app will contain two windows, one manager window, for the therapist to register a child or send a word to the ROS topic, and one window for the child to draw on. Now to test this, we require a touchscreen laptop or a connectable device like a Wacom. Our team does not have a touchscreen laptop, so we could not test this feature yet. We'll contact the client to borrow her Wacom if possible and finish this feature in the next sprint. To send a child to the program, we can use similar ROS topic command to register a child or log a child in. The robot receiving the signal will say hello to the child, which in this case, Johnny. This video is captured before fixing the bug B142, which is the error of not able to distinguish new child or old child. What we can see here is the robot saying welcome back to Johnny, since it is treated the received message as this is not the first session of Johnny, i.e. Johnny is an old child. This issue was later fixed and tested, and the program can infer from the message received to know if the child is new or old, hence to say hello for the first time and introduce itself, or just to say welcome back. In general, all blocks for this project have been resolved in this sprint. Therefore, Sprint 3 would guarantee a smoother developing progress, as team now has a baseline of code to work on and also has a clearer idea of what to do next.